Let's take a look at 7.6, inverse trig functions. So first let me go and show you sine and cosine. So I have the graphs pulled up here of sine and cosine. The one in yellow is sine and orange is cosine, of course. So we're looking at inverse functions. So literally, what is the inverse of sine and cosine? But to do that, you have to, well, we can see that the function is not one-to-one. Both of them are not one-to-one. None of the trig functions are one-to-one. So you need to restrict the domain so that you end up with a one-to-one function. And one of the these are the standard restrictions that you have for sine and cosine so that you end up with a one-to-one function. So normally, and there you can change it a little bit. I've seen different books through the years that have maybe a slightly different restriction, because you could restrict it, you could start over here and sine goes like this. You could start from pi halves to here, but it's kind of silly to do that. But so you generally have a standard restriction for your sine and cosines so that you end up with a one-to-one function. So now you can see that all of these pass that horizontal line test, and you have one-to-one functions. So that's the standard restriction. You don't have to memorize it, just kind of get a feel for how they're doing that restriction. And they get kind of, a little more strange when you're looking at secant and cosecant, because you have to bounce around the vertical asymptotes and stuff like that. So I don't commit those to memory, but you have a feel for what's going on. Okay, we'll focus on sine and cosine the most, of course. The big three and tangent. So the next chart, and this chart is, I don't think is in your book, but it's going to be in just about all these books we use. The next chart, same sort of thing, is we're defining now the inverses of sine and cosine. So if you look at the, oops, I didn't mean to do that. If you look at sine, take sine here, and you look at the line y equals x, and you do its inverse, you're going to get that. So this is the inverse of sine. And note the domain and range will always be interchanged. Okay, that's what's happening here. So I'm going to go through and define it, a couple of these, and talk about a little more as we write stuff up. So let's go ahead and do that. And we'll talk about when we do the problems, you want to have your unit circle out as well. And then here's some more definitions. So let's define sine inverse, or arc sine, we say. And so this is just saying this is the range. So arc sine is in the set negative pi halves to pi halves, and that's, you can see that's the range from here to here of the function. And then the domain we already have defined up here as negative 1 to 1. So it's negative 1 to 1, which, right, that's the range of cosine. So the cosine bounces between negative 1 and 1, and so those are just interchanged. Okay, and then we have arc cosine. So we have y equal to arc cosine of x. And that is from 0 to pi is the range. And we write, so this is how this is the actual definition. Cosine y is equal to x. Or you could say it like this, or I meant to say theta there, so hold on. Or we have theta equal to sine inverse of z if and only if sine theta is equal to z. And I'm using different variables on purpose to not get confused with x and y. And these have the same domain and range restrictions, so with the same domain and range restrictions. Okay, and then you could also have theta is equal to cosine inverse. So you can write it like that if you want. And that does not mean 1 over cosine or 1 over sine. It's a little weird, but just be careful. If and only if cosine of theta is equal to z. So that's another way to write it, and that's how we normally see it. So let's look at a couple examples here. Let's suppose you have this. So we're going to use, you want to have this unit circle, just pull one up from the net or something and just grab the unit circle. I found this one, I like this one because it has both the radians and the degrees. It has the ordered pairs of all the special angles, and then I put this up myself to not forget that it's always x comma y. It's cosine theta. I'm sorry, cosine sine as xy. So it just gives me a way to remember that. So that's the one I like. And I think I might have it posted up on files. I don't remember offhand. Okay, so let's look at this example. I think I can fit it right here. So let's say, suppose you're asked, this is just finding numbers, and this is just getting started. Our goal, obviously, is to find the derivatives and integrals of these, but we'll start with just kind of review. So find arc sine of negative root 3 over 2. And so what I like to do is write that into like an equation form and then solve it. So you don't have to think of it like this, but I like to think of it like this. So I'll say let theta, and so that's the thing, is this is an angle, right? So when you're solving this, we are saying that this is an angle. So arc sine, and you think of these interchangeably when you say arc sine and sine inverse. So it is an angle. So I'll say theta is that angle. So theta equals arc sine of negative root 3 over 2. And that is true if and only if we say then sine of what angle is equal to negative root 3 over 2. So that's how I like to kind of go about it. That's what you're really being asked. So this is where I picked this one on purpose, because check this out. If you use the unit circle and you look for negative root 3 over 2, that's sine, so it's your y value. Negative root 3 over 2 is over here, right? Yeah. So 5 pi. Oh, wait. Okay, so you have this is what I was trying to show you. So you have this value and this value. But what is, so theta would equal 4 pi thirds or 5 pi thirds. But what is our domain of arc cosine? And then you got to go back and see what are the values. So what values can this be? Well, those values are between negative pi and pi halves. Neither one of these values are between negative pi and pi halves. So what do? Well, basically you have to go negative angles. So use, the punchline here is we use, so not in range. So use negative angles. So that's what you have to do or end up doing. And so what you'll do then is go from here and you'll go negative down. So if you go negative, then that becomes negative pi thirds. So yeah, so if you start here and go this direction, then it's this angle, right? But so you go negative. So it's negative pi thirds. So theta would be equal to negative pi thirds. So that's, and there will only be one when you talk about inverses of sine, cosine, tangent, etc., because it's one-to-one. It's not like you have two different situations. You can't have both of those. So this one is not in the domain at all or range at all. This one kind of is like the location of it, but you have to use the negative case because that is how it's defined. And again, I'll show you. It's right here. Okay, so your arc sine has to be in that set for your theta. Hopefully this is a review for you a little bit. Let's do another one. Bring this back over. So let's look at this next example. So we'll jump to secant inverse. So find secant inverse of 2 over root 3. And so let's remember that secant theta is 1 over cosine theta. Okay, so and then what we'll do, same as before, we will let theta equal secant inverse of 2 over root 3. Okay, so what we have then is, then you ask the question, secant theta, so secant of what is equal to 2 over root 3? But that's just 1 over cosine, so that's really equivalent to saying cosine theta equal to root 3 over 2. So kind of a standard thing to do, kind of standard practice. If you can change the sine and cosine, that's usually better. That's usually what you want to do. So if you can, right, if it makes sense. All right, so then what we did then, so which cosine of what is root 3 over 2? So that's when you go back to your unit circle, and cosine is your x value, and so you're looking at this value here. So and always use radians, don't use degrees. That's just for you to know there to make a note of, but always using calculus radians. So that's pi sixth. So that implies theta is equal to pi sixth. Okay, and that is in the domain or the range for secant inverse, which is 0 to pi, which is what we needed to have. Okay. So then you go back, and let's just kind of clarify here. Then you go back to what our cosine is, or no, what was that? Secant. Just make sure it's in secant. Secant inverse. So you're secant inverse, and so you're 0 to pi. So the value is out of between 0 and pi, and it is. So negative. So pi sixth is in this interval. Okay. So now, so look at a number of those cases, and let's look at this. They have a couple limits in there. So here's another example for what we're doing. So when you do these limits, just use the graphs. I mean, just find the graphs and use them. So limit of cosecant inverse of x as x approaches negative infinity. What does that equal? So let me be a little more clear on this one since I'm not like in class. So evaluate that limit. And so what you do is you go to cosecant inverse and just look at the graph. So cosecant inverse, or arc cosecant, is this guy right here. So what's the graph doing? It's kind of a weird graph, right? It kind of starts here and then goes, starts here and goes that way. So as you're approaching is this positive or negative infinity? Or does it matter? This graph doesn't matter, huh? You're approaching negative infinity. So you're going negative infinity, so the graph is approaching 0 as you go out. All right, so that's all you got to do for, not for every case, but for those special values, you just kind of look at the graphs and see what's happening. Okay, that's the gist of it. So make sure you study these, be familiar with them. You don't have to memorize everything. You'll be able to look them up. But focus always on your sine, cosine, and tangent, both the graphs and the restrictions, and then their inverse graphs, all of those. Get a feel for that, and then study the rest, but don't worry too much about those. Let's see, there was more definitions down here, I guess. Was it arctan? Oh, this is just the definitions. So how I did them here, this is just writing out the rest of the definitions of arctan cotangent, not just the graphs is all. But this also, unit circle, make sure you can use that and go positive direction, which is this way, or go the negative direction, which is this way. That kind of stuff. Okay, next we'll get into derivatives, so trig functions, and I'll just stop this video, make it a little shorter, and then we'll get into integration, and that's it for 7.6. So probably 2 more.